I'm Clayton Wagar. I lead our AI activity inside of our cloud and enterprise strategy group for Nokia within our IP division.
Hi, I'm Upak Jha. I'm just taking care of the IDA senior PLM for the Nokia here.
So Rupak and I will be showing you the SaaS version of IDA. So we talked about IDA has a number of different deployment models from on-prem, depending upon how you want to integrate it within your existing, if you have an existing Kubernetes infrastructure. What we'll be looking at now is the SaaS version. So this is deployed in the public cloud. It's used by enterprise customers of ours to manage their networks on their own premises. And so what you'll see is a lot of DNA shared between the IDA on-prem version and the IDA SaaS version. The user interfaces rhyme, but they don't match exactly, right? So you're going to see some differentiation there. That just gets to the deployment model, right? So we're providing a lot of ancillary services over and above that you might stitch together if you have an on-prem version based on your own requirements. Here with the SaaS version, we're obviously providing much more of a bow around those things. So there's things like a data lake and other portions that form the whole of the SaaS product. So when we look at sort of the key things for day 2 operations in a data center, what we're going to be focusing on today, showing you, is app connectivity from end to end. One of the key pieces that you want to take a look at, obviously alarming. Some of the earliest network automation was really around log collection, alarming, and discernment of what's important inside of a series of events. That's part of it. Performance as well. So sometimes you have sort of hidden impairments that may not be obvious from the logs that you have, but you have application degradation, and so you have the performance element as well. Of course, the change request portion of that, we talked about that quite a bit. We've had some engaging questions here talking about things like configuration drift and comparing between 2 different states. I know my very first question whenever dealing with something that's changed is, what did you do? What changed, right? We always want to get to that origin event. I'm not going to drain the slide. We have it here, and we want to make the most of our time. But just the idea here is that there are any number of things that we can be collecting from the network if we're doing this, certainly in an all manual operation. We have to go to potentially every different type of role of device in the network. We have to understand where the network is transiting over a large network, what subcomponent it's transiting. We have all of these different types of pieces of instrumentation that we can collect, and so therefore, in a purely manual model, that becomes pretty much gated by the ability of the human to operate that. What we're going to show you today is some AI and some non-AI tools, which will hopefully compress that down to your root cause analysis, getting to something much quicker than you otherwise would have. Last slide, because the demo is the best part of this, but we wanted to sort of highlight some key pieces of what you're going to see. Completely model-driven, right? So there's no sort of fancy scripts on the backside that are doing have some sort of embedded logic. All of this is based, just like IDA itself, is based on the idea of being model-driven. When it gets to reliability, we have 2 pieces here, the reliability and the accurate reasoning. So as you look to implement AI tools on top of this, we have to be cognizant of, number 1, yes, hallucinations and context windows and accuracy of the model. But in addition, we can't just be consuming AI tokens like crazy, right? If we put AI in everything, we're ultimately going to be paying a big price for that if it runs in the cloud. And so we've put a lot of thought into the efficiency of gathering the information, again, being discerning what's important about that, doing the filtering that's necessary, and then reducing the token count. That helps us with accuracy and also ultimately helps us with cost, right? You'll see what we have here is a multi-agent workflow. So we have multiple models that are working here. We'll walk you through exactly how those are interacting. Some are doing tool calling, right? And some are being used for the planning purposes and reasoning purposes. So with that, I think the best part is to get the demo started. What we're going to show you is an actual hardware, real spine leaf network. It's a very large network. We're going to show you subcomponents of it. There we go. So we've got a classic 3-tier here. We've got a CLO, and we're going to introduce a network impairment here in between 2 of our application servers. We're going to introduce a network impairment. We're not going to do that, again, sort of drawing on what we've seen already, not going to do it at the configuration level. We're not going to do it by downing a port. We're actually going to go and impair the fiber so that we don't have light down on either side, right? So this is sort of a bit of a hidden impairment that doesn't necessarily start to cascade other pieces like BFD and the protocols on top of the port. So we'll have to go in and do a root cause analysis on exactly what happened with a backhoe, right? Or if or someone tripped over the fiber in the network.
Okay, so we have just gone to the slide. We have just seen the topology, and the the action behind the topology is we want to first understand where our VMs are located, and then we can just try to find out the path between those VMs. So as a network engineer, it is very difficult if you have big network to find the whole path between the two different applications which are just hosted on the servers. So the first point which we have to find out is what is the path which looks like between the two different VMs here. So for today's demo, we are taking the VM2 and VM3 as our source and destinations, and we will try to find out the path between them. What are the possible paths which can be possible here? I'm not able to minimize this. Yeah. So we go to the connectivity diagnostic page where we are just selecting the source, which is a VM2 here, and then we will select the destination. So here we will just list down all the VMs which are present in your network from the application perspective, and you can just search between what VM you want to do, see the path. In this case, the VM2 and VM3 both are the layer 3 domain VMs. So their layer 2s are different, but they are connected to only the layer 3. So that's why we are just seeing here the IP addresses and the VLANs here. When we run the tool, it will just try to find out all the possible paths from that VM perspective in the whole network. So, and then it will give us a very collapsed view of the network. So this network is a correlated network topology. It is not the full view of your whole network, which might consist of 50 or 60 switches. So here, if you see, you have only 10 or 12 switches, and you have the path from the source VM perspective, that these are the possible paths which it can take if the traffic will be flown from the source VM to the destination VM. So half of your traffic has been reduced. So it is just a superset, a subset of your topology. If you have a very big topology, you have reduced it to the 10 or 12 switches, and now your job has become very easy to find out the issues from here. Okay, now the question might be, okay, what I will do with this particular topology? There is no information on that. So we can just go on each of the module here of the source, leaf, spine, whatever modules you want. You can just expand it, and you can just get the information about all the VMs. Whatever information you need, you don't have to go and do the SSH to the VMs. The operator don't have to go there. They can get all the information from here which is required for your debugging purpose. So this is from the source instance perspective. Now when you go to the leaf, you will get all the logical objects which this particular VM will pass through this particular leaf. So these are all the logical objects mapping in that particular leaf. And from here you can find out the state of all the logical objects. What is the state and what is the value for that particular object in that leaf perspective. So this is from one leaf perspective. But now the question comes, what if I want for the whole topology? Because then it will give you a much more visibility that where the problem might be. So you can go to the deep dive, and you can just open it here, and you will see for the whole topology, the correlated topology, which is for this VM perspective, even for the leaf, spine, super spine, everything, you will just get it here. So from here, you can find out all the objects, modules, either it is on the leaf one or spine one or super spine one or the destination leaf, everything is green. That gives you an indication that all the path from the VM to the source VM to the destination VM, everything is fine. There is no issues right now in the system. So now let's try to go back and then introduce a problem here. So what I am going to do is I will just try to remove the link between the spine one and super spine one.
I just clarify. So you're shutting down a link. I thought you said you were just going to.
Yeah.
And
I was going to explain that.
okay.
Yeah. So we are shutting down the link in a way that it is not going to affect the interfaces status on the spine one and super spine one.
Okay.
So the port status on the spine one and super spine one will still be active. Only the protocol which is running on top of that will get affected.
Okay.
Like the BFD, BGP, OSPF, whatever the protocols you are running between those links, that will get affected, but the link status is still up. on the spine 1 and super spine 1.
Awesome.
We
It's
kept
obviously
level
link
five,
down.
but our budget ran out, so we now find a way to simulate it.
Yeah, obviously link up down is easy, so but the application
just-
stuff is hard.
It's a gray failure. So effectively, we don't have protocol activity on there, but we're still seeing light, which of course light would be a trigger to a number of other things there,
Yeah.
but that doesn't make for a great demo. So
Exactly.
Okay, so since we have done a interface shutdown, which is not bringing the port down, now we will just see the status between the VM2 and VM3. And tool will try to find out where the problem is and what is the problem. So it will just give us a view of the whole network where the problem is right now. So if you see here, the service status is still success. That means the tool is saying I still have an alternate path to go from the source VM to the destination VM. So my service will not get impacted from the traffic perspective as of now. But there is a amber bubble here that says there might be a problem on your redundancy, or there might be a problem on your performance, or there might be a problem on your link, which is connecting between a spine 1 and super spine 1, which can affect in the future. So the network operator has to start looking into that from the future perspective. So now the question is, okay, I got to know that there is a problem on the spine 1, but spine 1 has so many modules. Which module the problem might be? So we can go there. Just a moment. Yeah, so you can go there on the spine 1 and you can see the next hop module has a problem. So next hop module is saying that there is some problem, due to that the spine 1 is not able to get the next hop. Now why it is not able to get the next hop, that is our valid question, right? So for that we will just introduce our deep RCA tool, that is the AI based root cause analysis tool. So with this tool we are trying to find out the root cause. So with the Fabric Insight feature we are able to pinpoint where the problem lies. Now with the help of deep RCA tool we are trying to find out what is the problem, and then we will try to give you the probable solution for that, how to solve that. So when we run the deep RCA, the first phase is your planning phase. So we are running a fine-tuned a small model which will take the input of the topology and the config or the connect issues from your tools, and then it will just try to find out which all agents it has to run. So it will decide if I have to run all the agents or if I have to run only some of the agents. So based on the problematic statement, and then it will just send that information to deploy those agents. Those agents will try to get all the information, the correlated information. So the agent will not get all the informations which are for the whole network. They will only get the information which is correlated and only related to this problem. So by that way we get a very small amount of data, and then we get that data, we send it to the distill model to further fine tune it, and after that the distill model will remove all the noise, send it towards my large model, which will go for the reasoning stage, and the hallucination will not happen in that way. And then the large model will go for the reasoning phase, try to find out the patterns. Based on the patterns it will try to do the chain of thoughts, connect the dots and find out the reasoning for us. And here if you we have just found here the problem is a BFD failure, which is just creating the BGP peering issue here, where we have not told anything to the model yet. Along with that, we can just generate the report, and in the report you will get the evidence, the root cause summary, and what should be the problem solution for you.
So,
report.
Yeah.
Just give
so while you open that, I'm curious. Sorry, Jonathan Davis here. I'm curious on, ultimately we brought down it, even though it was maybe a gray failure. We still ultimately brought it down. How does this look if the link isn't down? We're just losing half a frames, right? So there's something where we either frames are being discarded or dropped along that link. So it's still up-ish. What does that look like?
So let's take a look at this report, and then we'll look at the performance piece in there.
Yes.
We'll give you a sense. There's another module there for performance as well. There's two more things I want to show you, but let's get this knocked out. But it's an insightful question. So
Okay,
we're headed.
so here we are just providing what are the instances which are getting affected by this particular problem. And this is the root cause, detailed root cause, where it is saying it is down due to the control detection timer expired for the BFD, which brought the BGP down, and which is creating the problem in the underlay. At the same time, if you see here, all the configurations are correct. There are no issues on the configuration perspective. So the agent is just looking for the configurations also, and it says the configurations are intact. There are no issues on that part.
Okay, so but the monitoring side of the system did detect that the peer went down, even though the configuration is compliant and in place.
Yeah, the totality of the logs and the instrumentation that were coming in allowed it to reach this diagnosis. Is that the?
Yeah, so it definitely came in on the logs, but there's a monitoring system somewhere here too, right? That's
so
monitoring the status of the.
Yeah,
of
so
the
monitoring system cannot detect it because right now our monitoring system is detecting the status of the ports, and the port status are still active.
Oh, so the monitoring system is tagged to the port status, not the protocols that are running on.
Yes, so that's why we have the different agents which will just try to find out. So our root cause, our demo purpose is that even if you have the different systems which are monitoring different things, even if one of the agent can pick the problem, you will get the root cause. So in our case, the log agent has picked the problem of the BFD down, and we got the issues here. So if you see here,
maybe I could ask a different way. Does someone have to notice that there's a problem, or does that agent get fired off that goes out and looks and see, oh, there's a protocol issue? So, you know, is it take a human to do something to know that there's an issue?
okay, as of now, we are just waiting for the input from the human to give the source and destination VM, because without that, in the network, you can assume that you have thousands of applications which are running. And if I will just put this feature, which will just go and auto correct the problem, it will create a more problem than the solutions.
Just the detection. That's all I'm asking about.
Yeah.
Not applying any remedy.
Okay, so in this current release, we are looking for the input from the human. In the next release, which we are bringing, it will be the auto detection based on the different agents or the different monitoring system, which we will integrate with our system, and then we will take the action based on that.
That's where you're. In this case, the quality of your failure actually kind of hamstrung you a little bit because you know, I mean, literally every product out there is if the interface is still in that original status, all of the other overlay, the rest of the network stack never changes, and so you don't get that alert, right? And so in this case, your failure actually, for that question, hamstrung you a little bit. But
the entry point to this is there's probably some dashboarding in place. There's probably some event triggers that are happening, and yes, a human would have to come in. Now we're kind of teasing out that autonomy. Level 0 through 5, right? At some point, we're in the 3 range here where we have the human in the loop. There's human-based interaction with it. At some point, in the fullness of time, will it be completely self-driving? I don't know. Perhaps I'll be retired by then. But the reality is that Google has been pretty clear about the fact that they do have complete autonomy there. The difference is, of course, they have a tremendous amount of parallelism in their network, and so they can make failovers very safely, understanding what they're...
Inconsistency within their own network, right?
What's that?
Inconsistency that they manage control, as opposed to...
When you're building it for an audience of one, you can have an absolute bespoke special snowflake, and it's going to be just fine. And here, we're trying to get broad coverage across a number of different...
So quick question on the failure, because I was trying to follow along what the value this was bringing. As I understand it, what you were trying to show is that you might have a scenario where forwarding on the port is down, the port's up. Maybe you have receive like, but you can't transmit traffic. So you're trying, okay, why? And then it noticed that BFD is down, and subsequently your IGP or BGP is down, and it's making that analysis that, hey, even though the port's up, these things are happening, and it's trying to point you in that direction. And I guess that's what I was trying to understand, was a little bit murky at first, that you brought back around, is that normally you would just say, oh, the port's down, that's the problem. But this is, in this case, the port's not down, but things are still dying.
That's right. It's a bit of a hidden failure. And then you compound that with, Yes, exactly what you said, which is I have my
Yeah.
I have my physical graph, then I have my underlay graph, then I have my overlay graph, and then I have some ECMP on top of that. And so all of a sudden you're sort of stacking these things together and it becomes a logic puzzle. Might be very fun for some of you,
You're-
but when the network is down and everybody's sweating, you're trying to
You're
get to-
collating failure domains
Exactly,
into an
that's right.
analysis.
That's right.
Yep.
Yeah,
That would normally take a network engineer to look at and say, okay, there's this, there's this, there's this,
that's
and you're wrapping it up into the agentic AI so that you can better understand the root cause
That's right.
by letting it analyze it.
That's right. And when we talk about customized models, the question we had a little bit earlier, which is why don't we create a model, sort of a frontierist kind of model that knows networking? That is work that our Bell Labs group is doing. It's called the Nokia language model. It's in multiple languages, Arabic, English, others. But it's not just knowing about networking terminology and terms and best practices. It's also then how do we build a model which understands specifically the graph, the different graphs that we have, and be able to constrain those in order to do troubleshooting, right? So this gets us to certainly is very impressive. First time I saw it, you take a look at it and you go, well, this is pretty fantastic. I think we only can improve from there the understanding of it as we have better model technology, if that's, I don't know if that's a term.
So I'm curious if I take this to, in the model that you use, and let's say I've got dark fiber and I've got this running on the other side, is it also able to understand that I don't have receive light on the other side and make that determination?
As long as we have reachability, if
I mean,
the platform can see all parts of that.
Right, assuming those pieces are in there. Yeah, I got you. I know you can't just see into something that you don't control.
Right, it's not that we took out our management route.
No, but in that case, if you're, if it's dark fiber and you own both sides of it and you have this on both sides, then the analysis might be, instead of saying it might be this, the analysis might be, you have received light on this side, but not on this side.
That's right, right. And they should know, because this is the way it's set up, we should know that it
So
should.
you would get a slightly different analysis if you saw both sides.
That's right.
Okay.
And speaking of which, we get to this confidence interval here. So actually the models go through. If they get score under 95% confidence, they rerun again. Although in the 400 or 500 examples you've given,
We have
it
never
doesn't
seen
happen,
that.
right?
Yeah.
They're pretty smart. But I love the evidence-based piece here. When I would commission circuits, you always had this idea of a birth certificate. You're running sort of performance testing. You're laying that down in the long-term documentation, so you know your baseline. Here, as you're doing RCA, with an incident, you can tack this onto an incident. This is a PDF. It could feed into another level system if you just want to take the data that's here and feed it into one of your bespoke operations platforms that you have. It's all right in place.
Yeah, so just to add,
Without a doubt.
just to add one more thing. So the reports which are being generated from the model, so we have to always put the evidence. Without evidence, it is of no significance. So that's why we are just keep on adding the evidence here, and then we will just put the confidence number for that purpose. Yeah, so
Performance before we run out of time. Two cool things I want to tell you. So we have performance as well. So if you're old like me and you set up a show command to iterate every 1 second on 2 sides and 2 terminal interfaces, so we can actually pick elements here and get the same type of information. We can even live stream it, so pick 2 and compare them. So have a live stream of the instrumentation that's coming off.
So I think your question was related to the error packets and all that. So we are just here tracking the error packets from that particular VM. So whenever there is any error packets, it will send the notification, or it will just start showing it here on the interface level that there is some error packets which are received on this particular interface for that VM.
So this is EDA SaaS. Is EDA on-premises feature available?
Not today, but stay tuned. They do have, again, they have different capabilities, some core DNA together, different capabilities, but obviously you would think that we'd want to have great coverage of these features across all the different areas.
This is a great feature.
There's,
Parity.
obviously we talk about AI, we're all laughing because any little button that has sparkles on it, we're all clicking now, right? Because when we want to see what happens with AI, the reality is obviously there's some infrastructure behind this to make AI work that would have to be planned on an on-premise installation. But that's not the only reason, but yes, that's why they rhyme. They're sisters, but they're not quite in stream yet. The last thing I wanted to show you, and then we'll make sure to make good use of our time, is there was a question about going backwards. We have Time Machine here. So because this is all powered through a data lake, right, it's actually accessing and doing this AI root cause analysis on the data that comes off the lake. We can actually go back in time a certain amount of time. So you've got Time Machine now. If we go back and say, what was it like 30 minutes ago? We run that connectivity test. This is now happening across the data set, not in the live network, right? So where this might be useful is if you see those type of impairments that maybe something happened which triggered something else, and then over time you have sort of a cascading set. Again, they become somewhat hidden from you. I know certainly plenty of times in my world, you get to something and say, well, this is what's wrong. Oh, well, it actually happens from this thing that happened over here, time of day, whatever it happens to be. So go back 30 minutes, you actually run these tests, including the AI root cause analysis, on the data as it was in situ 30 minutes ago, right? Which is interesting if you have some sort of, again, impairment that advances over time. I thought this was pretty cool, but because it does allow you then to go back in time and take a look at the connectivity as well, so you can see what it was like in steady state versus what's happening now, and do, at the very worst, a stare and compare. But of course, you're going to be using your AI assistant.
And even
So in this, can I see where the primary path is 30 minutes ago versus now? Because I found that was a lot of our failures, is that some failover had happened, and you get the report that 30 minutes ago I had this problem, but it's not there now. And it's like, oh, it's because we failed from path A to path B or C.
Right.
okay, so on the time machine, we can just see the states here 30 minutes ago. But what you are saying, that is in our future plan from the data path perspective, where I can give you the path, what path it has followed 30 minutes before.
Yeah, that's
Yeah.
because
Yeah, so this is already in the future release for us.
So, real quick question. I know you guys are short on time, but I'm curious. You get pretty heavily into the overlay and the underlay there, and the logical aspect of the network as well. Can you do comparative testing? I say, okay, if I ping test the underlay, it's this. But once I'm inside this overlay, whatever that is, that you can actually look at that and say there's a delta there between those.
Okay, so if you see here, the source to the leaf 1, that is your overlay, and from leaf 1 to the leaf 3, that is your underlay.
Okay.
So we take care of both the parts, and we just give you the information that if you just do the ping, at least from the latency perspective, what is the difference between the overlay and the underlay.
Okay. Or like if I change an MTU, let's say I change an MTU inside of a service overlay, maybe not in the underlay, is it able to look at that and detect something like that?
Yes.
So actually, we were preparing. We're not going to do it because we don't have time.
Okay. Sorry, I'm pushing you into all the good demos.
Because on Monday, I came into town. I live in Atlanta. I came into town. We were prepping for this, and he actually gave me an MTU-based MTU mismatch demo.
Oh,
because
MTU is never the problem.
and I laughed because I said, it's 32 years later, it's such a chronic pain. Like, two things in my life are consistent. Ping is not the ultimate diagnostic tool, and watch your MTUs. Like, those two things will solve 50% of
Know your MTU math.
So I brought up the MTUs, and
Yeah.
sure enough, we gave an example where there was an MTU mismatch, and the AI was able to figure that out.
Yeah, because you'll spend all day chasing that.
If I'd have had that when I was deploying broadband in 1998, I would have been in really great shape with DSL and MTU sizes and TPPoE and all that.
That might not be great.
Yeah, exactly. I'm only 26. Yeah, no, but it's a great example, and we did actually play with that because, again, chronic things that happen.
Yes.
Well, the reason I ask is a lot of things get into the underlay, the control plane, the physical links.
Yeah.
Not as many get into analyzing the state of the overlay and things of that nature. That's a lot harder to analyze.
We have a little bit of time.
Okay. Oh, good. Do you have one more thing you want to show?
MTU, you want to see?
If you can do it quickly. I don't want to. If you know how to do an MTU quickly, that's good. Show
Yeah,
this
just
to
give me
prove
2
out what I just said.
Just give me 2 minutes.
So we don't have to trust you.
It's just funny you mentioned that because that's the first thing I thought of too.
It's like software. It worked really great in test, right?
Oh, and IP don't fragment bits. That's the other one that always. You can tell I've been in the broadband world a lot because I have those pain points.
Those scars.
Just give me a moment. So this is the overlay MTU which we are going to change here. So right now it is on the normal default value of 1500. We are going to change some value which is pretty large than the interface MTU, and then we will see how it will just impact and what is the root cause you are going to get. I'm not able to commit it. Not able to see the mouse.
Oh, zoom is on top of your button. That's why you
Yeah.
can't see it. Okay.
So the real question is, when are you coming out with the stop, don't do that number feature? Don't use that number.
So zoom can be removed. Okay.
There you go.
Okay, so we have changed the MTU. And what it will do, it will just try to find out what are the overlay elements which are dependent on your MTU or the VLAN. And then if suppose that VLAN is down, what other elements will be down? Maybe it is the bridge interface, BFD, BGP on the overlay perspective. So we will go back to our topology again, and we will take the VM2 to VM3. Just give me So we are trying to find out if it is able to detect the MTU. So if you see there is a difference here, now your bubble is red here and your service status is failure. That means it is saying there is no path between your VM2 to VM3 because we are doing the MTU at the source leaf itself. So the traffic will hit the leaf and it will just get dropped there. So now we are just trying to find out what is the module which has affected here. So we are seeing it is a sub interface VLAN which got affected due to the MTU change. So now let's run the deparse. So this time it might be possible that based on the problematic state, it will launch the different agents. It's not the same agent which it has launched for the previous time, and it will launch, it will get some more data, go through the same process again, fine tuning of that, go for the reasoning, and then get the result for us. Again, it will start going for the chain of thoughts, start what is, okay, if VLAN is down, what if BFD is down? If BFD is down, BGP is down. So it will try to correlate those data and then give us the reasoning for that. And
I just want to clarify. So it's calling different agents, it's loading different agents depending on, like, as it sees different things going on.
Yeah, so
An
there's
agent for this, an
there's
agent for
multiple
that.
models at play. So one is what we call a planning model. So it decides what it wants to go find out from these other tools that it has to call. Then we have a tool calling model that specializes in gathering that data. Remember earlier I mentioned that compressing the number of tokens, doing that filtering up front on what's important for this particular root cause analysis is important for two reasons. Number one, it saves cost ultimately, but even more so, it creates higher quality outputs when we pass it off to for analysis, right? So being able to compress that data, or not compress it, but filter that data and discern what's important coming out of that, then we pass it off to the reasoning step, which allows it to formulate its opinions. Then a large language model is used to produce the report. That's really just a human language sort of motion there, but the models themselves are responsible for, one, a planning model, two, one that's responsible for calling the tool, like you see listed out.
Yeah, you're curating the context for your,
Exactly what it's
Yeah.
the curation step,
Yeah.
that's right.
And another quick question, is this part of EDA also multi-vendor, like some of the other demo that we saw?
The EDA SaaS follows with a short delay after an EDA release, so the capabilities of EDA are picked up. And so I asked that same question of the gentleman who's in charge of EDA, and he said, shouldn't be any problem, right? So if you pull that multi-vendor piece in, because we're using EDA as kind of the core and the intelligence of the system,
Okay.
you're going to pick up that same
So in theory, if I have a mixed network of Cisco and Arista and Nokia in the data center, and I wanted to do that MTU analysis, that's possible.
yes,
Because that's a neat trick. It's not a lot of people that are able to do that.
only thing is we have to add some additional agents. That's
Yeah.
the only thing we have to. So if you see here, your conclusion is there, the L2 MTU too large, and due to that, your VLAN was down between this.
Like you said, where was that 25 years ago?
Yep.
Yeah. At 3 in the morning.
Yeah, exactly.
Well, by the way, it's never going to be 9400 or 9500, something that your eyes will recognize at 2 in the morning.
Yeah.
3845, some number that looks like a port number,
Yeah.
right? It's really going to be tricky. So
1402 instead
That's right.
of 1400.
What are the scale limitations of this? If I've got a really large data center fabric, are there upper limits to scale? How far can this go?
Okay.
go ahead.
Very good question here. So if you see here, our network does not depend on how big your final network is. I am only concerned about the connectivity from the VM perspective.
Okay, so only the nodes
Even
that are
if
in
you have
path of the service or
Yes,
that I'm
This is
analyzing.
the subgraph
Okay,
this is the subgraph that's eligible for traffic passing for these between these
got
two
it.
endpoints.
Okay,
Which is why we kind of highlight here where this is ultimately a test between an endpoint and an endpoint. We're all network engineers looking at this as a network, but the reality is we have a plugin here that can go to OpenShift or VMs, vSphere or whatever it is, pull the metadata here to correlate the root cause out of there. So we're doing this is application layer from end to end, not just the network
So
itself.
we are putting ourselves at the source VM, and then we are looking for the network from this VM, how the network looks like.
Gotcha.
So it doesn't depend if you have 100 switches or 200, doesn't matter for us.
Curious about the data security, data protection. The models that you're using, are those Nokia's own that you're running yourselves, or are you using any frontier or third party? In other words, I don't necessarily want my data about my network being passed off to a.
You said model, I went to Yang model. But
Oh,
you're talking about
sorry.
the AI model.
The AI model.
The small AI models we have are our own, right?
Mhm.
We've done some reinforcement learning on that. We've optimized those to do the tool calling, the agentic tool calling that you see. And then the large language model, we're just using a public frontier model to generate that report and communicate in the human language element.
Okay.
But the heavy lifting is being done by our own models inside of here.
And so all that data stays internal. It's not shared with any third party during any of that process.
Yeah, completely our domain. That's right. Not that that would be important, would it?
Oh, not at all.
No, it's a strong concern, which is why I mentioned before about
Yeah.
in the fullness of time what happens here. We run models which are specific potentially to large customers. Certainly you can see for a lot of our telco CSP type of customers, they have very specific types of model that they want to run based on equipment that was put in a while ago. You can see where this takes us as an industry is now there's going to be sort of a model tech opening of
I'm going to say how many 5G mobility data centers are is this running in?
cloud and enterprise. So that's what I'm focused on. But yeah,
Okay.
certainly there's a lot of opportunity there.